Hello everyone and welcome back to another video. Today we'll be continuing our series exploring how to make a chess engine in Python. In this particular video we'll be taking a bit more of a deep dive into the legal moves functions, in particular going through whether the king is inside check. So as you can imagine, this is one of the most important functions within legal moves, since pretty much all of them revolve around whether the king is in check and that corresponding to whether the move is legal or not. So now let's have a quick look at the actual program. So if you're following along on GitHub, within the program it's on line 281 and it continues to line 360. So it's an 80-line function, so it's one of the longest inside here, but we'll go through it line by line, so don't worry if you're a bit perplexed by it at first. So initially we just initialize these variables. So first of all, we're initializing color and the piece number. So this particular piece number will be 6 since we're determining whether the king is in check. And remember, the piece number of a king is going to be 6. And then we initialize all of these. So it's the opponent's pieces, my pieces, and all the pieces. So the reason why all of these will come in very handy later is, first of all, the opponent's pieces. So we basically need to check whether each of the opponent's pieces, we need to iterate through each of the opponent's pieces and check whether any of them can attack the king in its current position. And now a few more things which we need to do is check my pieces and all pieces, since this will basically determine whether there are any pieces which can block the check from happening, i.e. if there are any pieces in between the opponent's piece and the king. And what we basically do is we also initialize attack and attack square and pinned piece. So I'll go through these in a bit more detail later, but attack square is basically just the square which the check is coming from. Excuse me. And pinned piece is basically any of the pieces of the king of the same color as the king which are pinned. Okay, so now what we basically do is we iterate through every single piece, and we have different functions for whether the piece is basically either a pawn, knight, bishop, rook, queen. Okay, so I'll just go through what this does a bit later. That'll become much more clear after we go through each of these initially. But before we do that is we first need to determine what the piece number of the piece in the opponent's pieces is. So this piece number is not going to be the same as this piece number, since this piece number is basically the piece number of the king, but then piece number over here is piece number of the opponent's pieces which are attacking the king. And our direction is basically the vector which joins the coordinates of the opponent's pieces with the coordinates of the king's coordinates. Okay, so if it's basically a pawn, then we have this particular function which determines whether the pawn is attacking the king. So let's just go through this line by line. So first of all, we check whether it's a pawn. That's the only way you can enter this if loop. And now if it's a pawn, then we have the following conditions. If it's a pawn and the color is basically equal to 1, or the color is, if the color is equal to 1, that basically means that it's white, which means the direction vector can either be 1, 1 or 1 minus 1. So, well, what does this actually mean inside our program? Well, let me just put up a chessboard. Okay, so this basically constitutes to the direction vector of 1 and 1, 1 and 1 minus 1. Basically mean it goes up a row and left a column and down a column. So this basically means a white pawn will be attacking like this and like this. Okay, and now if we go back to our program, and then otherwise, if the color is basically 0 and the direction is minus 1, 1 or minus 1, 1. So now if you notice, the colors might be reversed, and now this isn't a mistake since this color is basically for the opponent's pawns. Remember, the color variable which we have initialized here is the color of the king, but then the color for the opponent's pawns will be the other way around. So this is indeed correct. It will be color equal 1 when that's referring to the color of the opponent's pawns, basically. Okay, so now if these conditions are met, if either of these conditions are met, then we basically append 1 to attack. So attack is basically just the array of pieces which are attacking the king. So we append 1 to attack, and then we set the attack square to equaling piece, where piece is the coordinate of the pawn. So that's the first first if loop which we have. And now the next one which we have is dealing for knight attacks. So if the piece number is 2, and if the absolute of the direction vector is either 1, 2 or 2, 1. So what does this actually mean? So basically, if you recall, the way a knight moves is it can move in one of 8 directions. So a knight can basically move. Let me just move the knight over here. I know this is an illegal move, but we're just pulling the knight into the middle of the board. And now, basically, a knight can move from any one of these 8 squares. So can either move here, 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 or here. And now, basically, all of these squares are basically in an L shape. And the way we formally define an L is it either moves left, right, or up 2, and then moves 1 horizontally to that particular position. So regardless of the 8 squares it goes to, the absolute of the 2 x and y coordinates of its direction are 2 and 1. So if we go back to the program here, this basically means that if the absolute of the direction is 0 and absolute of the direction 1 is basically 1, 2, or if it's 2, 1, then we append that particular piece, the knight, to the attack array. And we also set attack square to equaling piece. So that's basically the knight attacks. Now if we go to the bishop attacks. So if you notice, the bishop attacks and the queen attacks, we can both group both of them into one category. And the way we deal with this is we basically we use vectors exactly how we did for determining the legal moves of a bishop and a queen. So we first determine which particular vector it is. So the scale is basically going to be the absolute of the x coordinate of the direction vector. So the direction vector can either be 1, 1, 1 minus 1, minus 1, 1, or 1 minus 1. But then that will basically be scaled in some uniform way. But since it's bishop, so the x and y coordinates will be scaled along the same vector, right? So this basically means that the scale is the absolute of either of the direction vectors. I could have also done the y coordinate here and made this a 1, it wouldn't have made a difference here. And now the vector, this vector is basically the unit vector in the direction which we're currently in. So it's basically the direction divided by scale and direction y coordinate also divided by scale. And now what we do is we basically check for each coordinate from the original coordinates of the bishop to the coordinates of the king, and then we check whether all of those are free. If all of those are free, then the bishop or the queen is indeed attacking the king. So and we also have one more thing which we need to consider here. We need to also check for pinned pieces. So what exactly would a pinned piece mean? So a pinned piece, if we go back to our board, it would basically mean something like this. Let's say our king would be here. Oh, I guess it crashed because obviously it is a legal move, so we don't really know what's going to happen. But pretty much, I'll just explain it verbally then. So a pin piece is basically a piece of the same color as a king locations piece, but then if it's inside the line of attack of the opponent's piece. So well, what this means is that if in our iteration of all the coordinates from the starting coordinates of the piece to the coordinates of the king, if we basically encounter a piece which is basically an obstacle, if the position is inside my pieces, then we append that to the obstacles array. Okay, so this obstacles array is basically all the pinned pieces which are inside the line of attack. So I'll just explain what the pin pieces are after I finish explaining this function. So how this function works is it basically goes through every vector, starting from the vector of the bishop, and then finally ending at the vector of the king. So it does a vector addition of the previous start coordinates along with the unit vector in this direction. And now if the start coordinates are in the piece, then it appends it to the obstacles array. And now if the start coordinates is out of bounds, or the start coordinates is the opponent's pieces, or the start is basically the coordinates of the king. If any of these conditions are met, then we basically need to break out of this while loop, So then we basically break, or we set valid equal false. Now, if the start coordinates are equal to the king coordinates, then we break because valid is true, which basically means that the check is true. So otherwise, we basically set valid to equal false. So now, basically, we have our obstacles array. But then one important thing is that the obstacles array will only be, the pinned pieces will only be there if there's only one piece in between the way of the direction vector of the attack from the bishop to the king. So that is a bit of a mouthful, so I'll just explain it using the chessboard. Just give me a moment, I'll pull up a chessboard with an example I'm looking off for. So if we basically consider this particular position, we have the bishop, which is over here, and the bishop is attacking the king. But neither of these knights are basically pinned. And now the reason why is basically because if we imagine moving this knight to here, then there will still be a piece which blocks the check from the bishop from occurring. However, this particular bishop is indeed in a direct line of attack to the rook. So this bishop is pinned, however neither of these knights are pinned. So we need to basically implement this inside code. So the way we do this is we first iterate through each coordinate vector from the vector of the bishop or the rook to the king. And now we append to obstacles as necessary. And then after we do this is, first of all, if valid and length of obstacles is 1 and the coordinates is in obstacles. So what this means is, once it reaches the king position, that's still treated as an obstacle, since if we imagine start to equal the king position, then start will be in my pieces, since the king is indeed in the pieces, and then it will be appended to the obstacles. So if the length of obstacles is 1, then that's basically fine, since we know that every time there'll always be the obstacle of the king, but that's not actually an obstacle basically. So if valid and the length of obstacles is equal to 1, and coordinates is inside obstacles, if all three of these conditions are met, then it's a direct check. So we basically append piece number to attack, and then we set attack squared to equaling the piece. But however, if the length of obstacles is 2, then this basically means that there's one more piece which is inside the way, and then we basically set pin piece to equaling the obstacles, and then we set attack square to equaling the piece. And now, if the length of the obstacles is greater than 2, like it is in this particular example over here, where there are 3 obstacles between the bishop and the king, then there is no pinned piece. So there is basically no threat coming from the bishop. So that's basically the how we went through the bishop and the rook. They're basically identical. The only difference is that for the rook Leal moves, we have this particular few blocks of code, and all this determines is which unit vectors there are. So there are 4 different possible unit vectors which they can be for the rook, but for the bishop, they can be determined like this. For the rook, they're determined like this. So I'll just leave this to you as an exercise to work out how exactly this code works. But just as a quick hint, I'll give you a clue. Basically, a rook can either move, it's either x coordinate or its y coordinate is 0. So you can determine the unit vector like so through this following if loop. Okay? But otherwise, we just implement the exact same code which we did over here for the bishop and the queen. And now, for a queen, the queen can basically enter either of these if loops, either as a bishop or as a rook. So that's basically it for this particular function. It was quite a daunting function, but we got there at the end. So finally, all we have to do is just return whether the piece number inside attack is greater than the minimum attack. So what this basically means is that whether the piece number, which is the king's number, is greater than the minimum attack. So this condition will always be met, but the reason why we had this is because we initialize attack to having float infinity as one of their variables. The reason why we do this is it basically just saves a bit of processing time. It's a bit of an advanced thing, but don't need to worry about that for now. So if the piece number is greater than the minimum attack, then we basically return true for it being check, as well as the attack square and any pinned pieces which are present. Now the pinned pieces are very important in determining the legal moves, which we will go through in the next video for deciding the legal king moves and also all possible moves. So that's pretty much it for this particular video. I really hope you enjoyed watching. Hopefully you learned something new about how we implemented the determining whether it's check for a king or not. And if you enjoyed this video, please be sure to leave a like and subscribe. Also check out my GitHub if you would like to do so, to follow along with the code. And I hope to see you in another video next time. Thank you very much for watching. Bye.